Welcome to sublesson 6.3, Understanding File Types and Attributes. So let's first talk about file permissions. We learned before that a file has an owner and a group, and it also has a set of permissions which we've not yet covered in detail. You'll notice when we do a long listing on a file that there are 9 permission bits that say who can perform which operations. Those operations include reading, which is allowing a user account to read a file, open the file, and read it. There's the write permission, or the write operation, which allows the modification of a file, but not the removal of a file. There's execute, which means that the kernel of the system will actually execute. So you would never assign this to any file except a script or a binary, something that can be executed by the system. The execute bit on a directory means you can list the contents of that directory. So if the execute bit is not set on a directory, you can't list it, you can't perform operations on that directory. When we talk about file permissions, we discuss them in octal, which is a numbering scheme. You might be, of course, familiar with the decimal system, where you start counting at 0 up to 9, and then you go to 10. Or you might be familiar with binary, which is just zeros and ones. Octal is 0 through 7, and that's the numbering system used to describe file permissions. So let's look at some specific examples here. Here's an example of a long listing of the /user bin passwd binary. This is the file that we use to change the password for a user on the system. Let's look at the permissions in detail. So we have 10 bits here, but only 9 of them are relevant for our current discussion. So starting with RWS, these are user permissions. These are permissions that the owner of the file is allowed to take on that file. So in this case, we have permission to read the file, we have permission to write to the file, and then the setuid bit is set. We talked about the setuid bit before. Setuid means run this command under higher privileges. So if I ran the passwd command as the vagrant user, it would in fact increase its privileges to run as root, since the passwd command needs to do privileged operations. The next 3 bits are the group bits. So these are what operations a group is permitted to use on a given executable. In this case, the group is allowed to read the file, it's not allowed to write to the file, notice the dash, and it's allowed to execute the file. And finally, the last 3 bits are for everybody else on the system. So we have the user, which in this case is root, we have the group, which in this case is also root, and everybody else on the system. So everybody else is allowed to read the file, but not to write to the file, and they're allowed to execute it. So looking at our table, we can see what the octal representation of this would be as well. So starting with the user permissions, 4700. 4 means that's set for the setuid. It's a special version of the octal bit. For setuid, it's not so common to use that one. 7 means that the user has full permissions, read, write, execute. They can do everything on this file. 50 is what we have for the group, 5 being read and execute. So we have we count 4 for the read and 1 for execute, gives us 5, and then 0. And then the last one is everyone else's permission, which is 5. So read and execute is octal 5. Let's learn a little bit more about the setuid and the setgid. So recall from the process's discussion that executable files can run with elevated privileges, and similarly for setgid, all of the files in a setgid directory inherit the group permissions that are already on that folder. So let's run through this example on the slide. First, we make a new directory, /temp/test. Then we change the permissions on it using the chmod, the chmod command. So we use chmod 2755/temp/test. Then we list it so we can see our work so far. We use ls-ld to list the directory. So the very first bit in that output, the D, indicates that it's a directory. We knew that because we used makedir to create the directory. The next 3 bits, rwx, that's the 7 from the 2755. This means that the vagrant user that created this directory has full read, write, and execute permissions on the directory. Next, we see r-s. So these are the group permissions, and we can see that the S is where the X would normally be. So this section is the 2 and the 5 from the chmod command. So the vagrant user can read, execute, and then any new file that gets created in /temp/test will inherit the permissions from the directory. And finally, all users can read and execute. So then we follow this up by just showing an example, touch/temp/test/file. So we make a new file in the test directory, and then we list it, and we can see that the Vagrant user and the Vagrant group both have read and write permissions to the file. Here's some further examples with octal notation of permissions. So let's kind of run through each row in the table. Symbolically, in the first example, this is what you might see on a file with no permissions at all. That will be represented by octal 000. User has no permissions, group has no permissions, everyone have no permissions. So that's the very most basic example. The next example is 111. This is everybody has permission to execute on this file, the user, the group, and everyone. On 444, we show that everybody can read this file. So if you're following along, we can see that you start at the left side with the R is a 4, the group is a 4, and everyone else is a 4. So that would be read, read, read. Writes would be 2s, and then we get into mixing some of them. So the 4755, this mimics the user bin passwd command. This is a setuid with the 4 indicating setuid, and then 755 means that the user can read, write, execute, the group can read and execute, and everyone else can read and execute. Another really common permission is 644, meaning the user has read and write access, group can read, and everyone else can read as well. Let's talk about file types. There's more than just files and directories, although those are very common types of files on the file system. There's more than just that. So when you're looking at the file permissions, we're talking about the very first bit here. It's always represented by some letter or a dash. If it's a dash, the file is just a regular file. You can edit it, it might be an application, it's just a file on the file system. If the first bit is a D, it means it's a directory. But then there's several other types. There are character device files and block device files that start with a C or a B. You'll often see these under /dev, for instance. There are local domain sockets. These are used for inter-process communication when one process needs to talk to another. There are named pipes, which are also a way to communicate with a process. And there are symbolic links, which means that one file points to another file. They're created with the ln-s command. So let's see some command line examples of editing files. So I'm logged into my CentOS box as the Vagrant user. First command I'll do is touch file, and I'll use this command to list the file immediately after I touch it. So I've created a new file. We can tell that it's a file because the first bit is a dot. Next, I show rw-. This means that this would be octal permission 6. It means I have the ability to read that file. I have the ability to write to that file, and that file is not executable. So if I tried to execute it, like if I tried to do /file like I would an executable file, you can't do it because there's no permissions. The next one is rw-, so the group. These are the group permissions. Also have read, write, and no execute. And everyone else has no access to the file at all. So that was the octal way to refer to it when we discussed terms like 660. I can change the permissions. I could use the chmod command, and I could say 600 file. And let's look at it again. Now I've given read and write permissions to the user, and I've taken away read and write permissions from the group, and the everyone permissions stay the same. I could also change it to be 400. And now it's only read only. I've taken away write permissions. So we subtracted 2 there. I could get everybody read write permissions by typing chmod 666 on the file. And if I list it, we show read write, no execute for the user, read write, no execute for the group, read write, no execute for everyone else. So that's the octal representation. You can also refer to these with the chmod command in mnemonic form. And this is maybe a little easier to get started with until you fully understand the octal version. I can say for user, give read write to the file. Now if I list it, the user has read write. Now, under this version, unlike the previous examples, because we're only specifying user permissions here, we're not specifying group or everyone. So all we see is change to the user. If I, for instance, ran chmod u equals r, that would say give read permissions to the user. Now I've subtracted write permissions for that user. Or if I wanted to add execute, I could say it like this. We can use a different mnemonic form to just add or subtract permissions from a given user. We can say chmod u plus rwx, saying give the user full read, write, execute. We can say group minus read, write. We don't want to give the group any permissions, read, write, x. And everyone else, represented by O, minus rwx. So this should give the user full permissions, the group, and everyone else no permissions. Oops, and I have to specify the file. Now if I look at the permissions, it's just what we anticipated. So we can refer to it either through octal or mnemonically. So let's look at some more examples of messing with the file system and file permissions. So under /temp, we'll just write a quick script. Here's a handy shortcut you'll find sometimes. We can redirect all the output until we see end on the screen and send all of the output to script. So we're going to write to a file called script in sort of a non-traditional way. So I'm going to create a new script. This is the syntax we learned in lesson 2 when we talked about scripts. And I'm going to say echo hello world. Very common programming example. And I'm going to say end to end the script. So if I take a look at that file now, it's just like I had edited a file called script with VI and typed it in. It's just a different way of editing it. You'll find that handy sometimes. Now if I wanted to execute this new script, I can't currently execute it. I can't just say /script, which I normally would do. First I have to change permissions on it. So I need to make sure that this script has execute permissions. I might do chmod 700 script. So let's look at the permissions to make sure we have them right. Read, write, execute. Now if I type /script to execute that script, it prints out hello world as expected. So now we can kind of get an understanding of what the execute bit does. Let's look at what a symlink might look like. So if I touched a new file, we can see this is just a blank file. Read, write, read, write, read. Now I can make a symlink to this file. ln minus s to file. So ln means create a new link. Minus s means make it symbolic. And then I want to make a symbolic link to file called, we'll just call it symlink to make it really easy. Now let's take a look at the symlink file. We can see here, symlink, it starts with an L, so we know it's a link. The permissions on a symlink are meaningless. The symlink permissions are the same as the file for which it's pointing to, and we can see what it's pointing to here. We can see that file is a shortcut to file. So if I type cat symlink, it prints out file because that's the contents of file. One additional example we'll give is changing the ownership and the group of a directory. I can make a new directory, make dir /temp/new dir. And I can change ownership with the chown command, chown. And I can say, well, let's just look at the file permissions first. Temp new dir. We can see, oops, I need to use the -d, ls-dl, temp new dir. Notice that the flag order doesn't matter. DL, LD is the same thing. So we can see that this is a directory because it's prefixed with a D. We can see that vagrant user has read, write, execute permissions on it. The group has read, write, execute, and everybody else has read and execute. Now I can change the permissions. I could say sudo chown -r to be recursive, meaning that directory and every file underneath it will be changed. I could say bwhaley:vagrant. So I'm changing the ownership from the current owner of vagrant to the new owner of bwhaley, temp new dir. And now if I list it again, bwhaley owns the file, owns the directory rather. I could also change the group. I could, for instance, say sudo chgroup -r to recursively change, or I could drop the -r to not be recursive on this directory. I could chgroup to be Whaley. I'll use admins, which is the group we created previously. Neuter. And now if I list it, notice I use bash shortcut. This indicates the last argument of the previous command. Shortcut for /temp/neuter. Now the directory is owned by the group admin. So we've just changed the ownership of the directory. So those are how you can manage permissions and ownership on the Linux command line.